Okay, let's see if we can graph a polynomial. So we want to do number 10 and 11.3, which is graph f of x is minus 5 times the quantity x squared minus 4 times the quantity 25 minus x squared. Okay, what do you start with? Start with, okay, so I have two conflicting thoughts. FOIL and factor.
Oh, yeah. I say factor.
Right?
I see lots.
Both are actually good ideas, at least in parts. I'm going to start with FOIL, but I'm only going to do part of it. Yeah, I'm definitely going to go back to this to factor. Cool? I got to pick one, and Joe said
No,
FOIL.
go ahead. I don't care.
No, really, it's a good idea anyway. So I'm going to go with it. So if I FOIL this out, and the only thing I'm going to care about is the highest power term here. So what's the most x's you can get here?
X.
Yeah, you can get an x to the fourth, right? Okay, so there's going to be some x to the fourth plus some garbage. I don't really care what the garbage is, so I'm not going to actually fully FOIL. What's the x to the fourth coefficient?
5. Negative 5.
Yeah.
So I got negative 5 times 1 times
Negative x.
Oh, so it's
times
just 5.
negative 1, so I'm going to get positive 5. You guys cool with that?
Yeah.
So this is going to look,
Pretty good. Kind of thing.
yeah, this is going to be parabola kind of thing, right? Not actually a parabola because that's a square. So this is going to be a little bit steeper and a little bit flatter in the middle, parabola, pointed up on both sides. Okay, so upon seeing that, I'm thinking something like this. Okay, now let's try the factor approach. So you guys said there's difference of squares all up in this thing. So f of x is minus 5 times x plus 2 times x minus 2 times
X plus and minus
5
5
plus or
minus.
minus x.
Yeah.
5 plus and minus x.
So you're making your 5 at positive.
Fricked up. Don't frick up. All right, so what is my next step? What was the point of this?
Those are your zeros.
Yeah, good. The zeros are all here by inspection, right? So just hit this thing with a zipper, right? Zero product rule. So either negative 5 is 0, or x plus 2 is 0, or x minus 2 is 0, or 5 minus x is 0, or 5 plus x is 0. Right, which really tells you that your zeros are where?
Plus and minus 2 and plus and minus 5.
Plus and minus 2 and plus and minus 5.
We have double 0 and negative 5.
Double 0 at
Negative 5?
negative. No, I don't. I have a single 0 at negative 5 from this guy, and a single 0 at positive 5 from this guy.
What about that first negative 5?
Ah, this first negative 5. So negative 5 is 0, right? That just isn't true. There's no x you
Yeah.
can plug in to make that true. That was really just there to screw with your brain. Thanks.
That won't affect the graph in any way then?
So the negative 5 is going to affect the graph.
By flipping it upside
Well,
down. Oh, no.
yeah, so that's why I did the FOIL thing, was to figure out whether it was flipped upside down or not. You guys see that? So yeah, it's affecting the graph, it's smushing everything. Like, or vertical stretching everything, depending on how you look at it. Probably better to look at it as a vertical stretch. Cool? Alright, so what do I actually know? Right now, on my picture, I know what?
Yeah, it's crazy. Yeah, zeros.
Yeah, there's zeros. So let me put zeros. So there's some at minus 2 and plus 2.
And -5 and +5.
and -5 and +5. I hope those are roughly equidistant. Yeah. Okay, so I got zeros there. And then I know it looks like a parabola ideally, right? So I know it goes up on this side and up on this side. And then I know it goes through -5 somehow. Is it a straight through from top to bottom, a straight through from bottom to top, or a tag off either side?
It's what it grabs.
So,
Goes through it, huh?
so how do I know it goes through it?
Doesn't have a multiple zero there.
Good. It's just
Well,
a
that's what you
single
said.
zero,
Yeah.
right? At -5. That's just this term. It's not squared. There's not another one. So it's got to go straight through. And now I know it goes from top to bottom as I go from left to right because it's already on the top over here. You guys see that? So I know it connects like this. Okay. Now that I know it's on the bottom just after -5, I'm wondering the same thing about -2, right? So does it go transversely through -2,
Yeah.
increasing, transversely decreasing, or tag off?
Transversely increasing.
Goes through transverse increasing. I know it can't tag off because it's a single zero, right? And I know it's got to be increasing because it was negative down here, and it's got to get to 0, so it's got to go through. Then I wonder the same thing about +2, right? It's got to be transverse again because it's a single zero. And it's got to be transverse
Decreasing.
decreasing because it's already above 0 and it's got to get down below. And then +5's got to be transverse increasing because it's already negative and it's got to make it up to positive. So I get this big W looking thing.
Could we also say that we know it's going to kind of be like that because if we zoom way out, it's just going to look like that?
Yeah, so if we zoom way out, it's going to look like x to the 4th, right? That's where I got those 2 arrows on the ends that I started with.
So we know it's not just going to go all wonky though. Like we just know it's going to kind of oscillate right there and then go back up.
Yeah, so I know it's not gonna oscillate more wildly. 1, because it's a polynomial, and 2, because I have all the zeros accounted for in here.
Pretty wonky.
That's cool with that? I also know this thing, since it's degree 4, right, can have at most 3 peaks and troughs. And this one has all 3, actually. That's cool.
Yeah.
There's one other thing you can know from this, which is kind of neat. Is this function even or odd? Or neither? So, to recall, how do you figure out whether a function's even or odd?
Whether both arrows go the same direction or they go opposite directions.
So that's whether the the degree is even or odd. I mean whether a function's even or odd.
Oh.
We have the negative x and the negative f of x.
Yeah, so you need to look at f of negative x, right? If it's f of x, then the function's even. If it's minus f of x, then the function's odd. And if it's neither of those, then the function's neither.
Looks even to me.
So if you plug negative x in here, you get -5 times negative x squared minus 4 times 25 minus negative x squared.
Well, it's even, because as soon as you square negative, it's on.
Yeah, right? We're squaring all the negative signs that we just put in there, so we'll lose them. And so we get back to f of x, which means this thing's even. Which means that my picture's symmetrical, right? So I can use that as a check. When I got a symmetrical picture, I might go check for even, right? If I get an even function, that tells me I'm on the right track. If I figure out the function's not even, then maybe my picture's a little dorky.
Why is the y-intercept 500?
Because it goes.
Why is the y-intercept at 500? Oh, this one?
Yeah. x is 0.
Because when you plug 0 in, you get out a really big ass number.
Yeah.
Yeah, so that's another fair point. I don't have a y scale on this picture. If I want to get a y scale, I'm going to need to test several different things. So I'm going to test at negative, or at 0, right, to get this height. I don't know that these heights are approximately the same. You guys see that? Like another perfectly valid picture for this thing would look like something like this, right, where the bottoms dip way deeper than the top. I do know that the bottoms have to dip to the same depth because this thing is even, right? But I don't know that they're not way deeper than this thing is high. They're probably about the same. But that's just a guess because I've graphed a bunch of these. Cool. If you want to actually figure it out, you should pick a number in there and plug it in, get out a height, plot that point precisely. Cool.